Decompression sickness. All divers have to contend with other problems besides cold, narcosis, and toxicity. The greatest and most enduring problem divers face, and still not fully understood, is decompression sickness. Decompression sickness, DCS, also called diver's disease, the Benz and caisson disease, is a medical condition caused by dissolved gases emerging from solution as bubbles inside the body tissues during decompression. DCS most commonly occurs during or soon after a decompression ascent from underwater diving. In 1906, the British Admiralty hired the services of a Scottish physiologist, John Scott Haldane, to solve the Benz mystery. Haldane first reviewed data gathered on sandhogs who built the Brooklyn Bridge, which was constructed from 1869 to 1883. He also conducted experiments in a recompression chamber. Haldane knew that sandhogs, coal miners, and divers all breathe compressed air, which has the same composition as air on land at sea level. Nitrogen in the air would enter the lungs during inhalation and then carried into the bloodstream, and from there would be forced into the tissues. This nitrogen was more than the body was used to holding. As early as 1878, the French scientist Paul Bert determined that the Benz was caused by excess nitrogen released from tissues and blood as pressure on the body was eased. Bert discovered that the nitrogen formed bubbles in the bloodstream that gathered around the joints, cut off the flow of blood, and pressed on nerve endings. On the basis of Bert's findings and other data at his disposal, Haldane experimented on goats. He put them under pressure and simulated various depths for different lengths of time. Haldane observed that when a goat has pressure-induced joint pain, it kneels, the goat's equivalent of bent diver's urge toward the fetal position. Haldane experimented by placing goats first 33 feet of depth pressure for various period of time, then at 66 feet of depth of pressure, and then at 99 feet of depth of pressure. He noticed that he could bring the goats from 33 feet directly to sea level pressure without any ill effect, but when he brought them straight up from 66 or 99 feet, they were clearly in pain. He then tried easing the pressure on the goats 1 atmosphere at a time, leaving them at the lesser pressure for various times before easing the pressure again. This method worked. It allowed more time for the body to eliminate nitrogen during exhalations and prevented excess bubbles from developing. By various adjustments to the pressure depth profile, the time exposed to those pressures and the time taken to ease the pressure, he could bring the goats to sea level atmosphere without experiencing pain or dying. Before he could test humans, Haldane had to create standardized charts that could be used by those responsible for hauling the divers back up. The charts had to be easily read and interpreted, especially since they would be used on boats in uncertain sea conditions. He came up with a set of 3 charts, known as diving tables, that correlated depth, time at depth, and time taken to surface. The charts also took into account excess nitrogen that remained in the body from a previous dive. In such cases, on a subsequent dive, the diver was allowed to spend less time at the depth. If a diver exceeded time at depth, Haldane included depths and times for stops to be made so that his body could release excess nitrogen before he was brought to the surface. This process is known as stage decompression. Haldane presented his research and charts to the Admiralty, which conducted tests using human subjects. Divers achieved record depths of 210 feet without getting bent. It was miraculous. Divers learn and relearn the history of decompression theory at every level of diving instruction.